All right, so last lecture we had a little bit of an interruption. So let's pick up where we were. I backed up a little bit so we can talk about the API stuff. But just a refresher, we're talking about application objectives 2 and 3 on homework 1, how to do those. So last time we saw that the server talks to the database using our CRUD operations. We can use either MongoDB, MySQL, or whatever other database you want to use. And as long as, in this class, as long as it's running in a separate container using Docker Compose, I don't really care what database you use. I do recommend MongoDB, though, as it'll cause the least amount of issues from anecdotal evidence. It tends to create the least amount of issues. Whereas MySQL tends to be a lot of debugging issues while interacting with MySQL and not necessarily debugging issues related to your understanding of the course content, which we don't like that. So when the client is interacting with our server, that's when we're going to use our HTTP request. The user is going to send a request to us, an HTTP request. We're going to parse that request, do whatever, check what it's asking us to do, and then our server is going to talk to the database using our CRUD operations. So we need to parse the request to figure out what we're going to do, and our GET request types, our method types, are going to correspond directly to those CRUD operations. If somebody's sending a GET request, they want to retrieve something. If they're sending a POST request, they want to create something. If they're sending a PUT, they want to update something. If they're sending a delete, they want to delete something. Now, this could be set up differently for different APIs. This is the way we're setting up for this course, because I think this way makes the most sense, personally. But this is the way we'll do it in this course, and hopefully out there in the real world, wherever you go as well. I think they should do it this way, personally. And we talked about put versus post. This is where we're kind of overlapping a little bit with what we did last time. But put versus post, they are both used to send data to the server. Yeah. Yeah. Yes. But for your homework, if you want to just straight up delete, that's fine. But what you would do is set a new field. When you create your SQL table, you would create a column for deleted. And in Mongo, you just add your documents with a deleted thing. And then in your retrievals, whenever you're accessing data, you would always say either where deleted is false. And then filter those out on the other side. And whenever somebody's updating with a put, you would say update where deleted equals false. And then do that check on each side. But you have to do the same checks regardless of database. So put and post are both to send data to the server. I did mention, I talked about this quite a bit last time. I'll give the TLDR of it. Put is idempotent, post is not. So post, there's information to process. For our purposes on the homework, that is generating the ID for the record that's being created with a post. But with put, when you're just updating a record, somebody's saying update record number 5, you just update record number 5. There's no processing. Your server just does the thing that it's told to do. No extra processing, no extra data generation. And the big difference is that put is idempotent. Sending 100 identical put requests is the same as sending 1. Sending 100 identical post requests is very, very different than sending just 1. So idempotent put should always be idempotent, meaning that multiple requests aren't going to make any further changes. And our put is idempotent. And there is no magic to this. If you have a put request, it doesn't have to be idempotent. If somebody says, hey, send me a put request for this endpoint, it doesn't have to be idempotent, but it really super duper should be. So there's no magic with a put request that says this will be idempotent. It's just the way that we as developers communicate with each other. If I create an IPA, and oh my goodness, I'm already thinking of later today. If If I create an API, there we go. If I create an API and I say this endpoint, if you use this endpoint, it's a put request, send me a put request, you should take that to understand that that's going to be idempotent. That's why I made it a put request, because I coded it in an idempotent sort of way, that I'm not doing any processing. So that's how we communicate with each other. And you should do the same thing. You create an API and you have a put endpoint, it should be idempotent. If it's not idempotent, change that to a post request to communicate that to people. Hey, and vice versa. Hey, this is a post request. This means it does some processing. I'm going to create some data when you hit this endpoint. So the same thing. If it doesn't create data, if you're not processing anything and you have it sitting there as a post request, change that to a put. Communicate that clearly to your users. But that's all it is. You've been parsing these things. You've been parsing requests by now. Hopefully you've all started project homework 1. I can say that confidently, right? You've all started at least. The expected deadline is Monday morning, so hopefully you've all got a good start on it. But when you parse these things, the method type is just a string in the request line, and that's it. End of story. There's nothing else to it. There's nothing else to it. It's just a string in the request line. There's no magic there. There's no hard and fast protocol that says if it's a put, it has to do this or else things should break. Nothing. None of that. It's literally just a string. But it's a way that we communicate to each other as developers so that we get the point across like, hey, this is a put. It's going to be idempotent. This is a delete. There's nothing special about a delete HTTP request. But if I have an endpoint that takes delete as the HTTP method type, you should expect something to be deleted. But it's just a string, it's just a word, just a way to make our APIs more self-documenting. Get is typically just idempotent. All you're doing is retrieving data. I guess it's technically possible to make a GET request that's not idempotent, but you shouldn't. It shouldn't change the data. Not to say that you'll always get the same response when you send a GET request, but it shouldn't change the underlying data in the API for all users. Put and delete are both going to be idempotent. Delete doesn't make sense to delete a record multiple times. You delete it once, it's deleted. You delete it again, it's already deleted. You don't get further changes, no further processing by deleting the same record multiple times. Post is not. I spent long enough on this point. I think y'all get it. Post is not idempotent. It could be, but if you have a post request that's idempotent, switch it to a put. But if you send 2 post requests, we're using post to create records. If you send 2 identical post requests, you're getting 2 separate records with identical data, except the ID is going to be different. 2 records will be generated with different IDs because the server is processing by generating the ID and attaching it to that record that was created. We don't let the users create their own IDs because then how the hell do we prevent ID collisions? You're going to have records with the same ID. So our server has to process that. It's post requests because it does some processing. And we have what's called a RESTful API. This one's a bit controversial. I'm part of the controversy of what is a REST API or RESTful API. But I'll talk about it. I'll get you prepared to choose a side on all the debates. REST represents representational state transfer, for what it's worth. And we're going to have HTTP requests define our RESTful API. So all the endpoints, our posts, our 2 GET requests, our put requests, and our delete requests, those are our 5 endpoints for our API. And that's going to be our RESTful API. It's talking about the HTTP side because that's how the public is going to consume our API. Our data is through that RESTful HTTP API. REST is not super well defined. I don't know if that's fair to say, but there's no RFC for REST and RESTful APIs. There's no hard and fast, this is the protocol, unlike HTTP, TCP, IP, WebSockets that we'll talk about. We haven't talked about that yet either. Multi-part form requests. Most things that we talk about in this course have an RFC, and that is the documentation, and that's what you follow. End of story. REST isn't that same way. It's I'm blanking on the individual's name, but it was somebody's PhD thesis. They wrote up their research, and they said, here's this new thing. It's called RESTful APIs, and published that. And then that's what is, that's where this all comes from, is that one person's dissertation. So there's no review process. We didn't, the community didn't get to argue and debate over what should and shouldn't be in there. It's just one person's thing that they said, you know what, RESTful API, here's a cool thing, and they published their dissertation on it. So it's kind of loosely defined because it's just that one document, but you can argue that document does fully define what RESTful API is. So I would say it's more so loosely understood. And I'll admit I don't fully understand what RESTful is and isn't, what makes an API RESTful and what doesn't. I know a lot about it. I'll talk about it here. But when you get to the nitty-gritty details of it, it's like, well, technically, there's a lot of that kind of stuff in this because it's kind of defined, but not through an RFC and very loosely understood out there in the industry. Everybody seems to have a different idea of what RESTful means. So we usually talk about it on a spectrum. There's not, this API is RESTful, this API is not RESTful. Usually your API is more or less RESTful. So RESTfulness, as we'll go through them, is like a set of criteria that you can meet or not meet. And if you meet more of those criteria and kind of embody the spirit of what it means to be a RESTful API more, then you're more RESTful. And if you ignore a lot of it, then you're just less RESTful. So I don't think it's helpful to say this is RESTful, this is not. Just say more or less RESTful. And you'll be in meetings like this almost certainly at some point in your career where a dev will say, let's add this to our API, and another dev will say, well, that's not very RESTful. So we kind of use it as an adjective. I might have backed myself in a corner. And adjective, right? To describe our API. Yeah, that's the right usage. Right? You gotta stick with science. I go into English and I make mistakes. So our API is, I would say it's mostly RESTful. There are some things about the API that do violate RESTfulness. But it's mostly RESTful. It's pretty RESTful. But that's the way we use that term in industry. So let's go through the criteria to be a RESTful API. One, it should be a client-server protocol, and it should be stateless. We're using HTTP. You don't have to have an HTTP API to be a RESTful API. You can use any protocols out there. We're using HTTP, which is both client-server and stateless, so big check mark on that. When we get to cookies, this is usually broken in a lot of APIs that we'll still call RESTful APIs because you want some API token. You want some state with the requests, with an API token, to be able to do things like rate limiting and validating access. Technically, that violates REST. I don't care. Nobody cares. We're going to have APIs with API keys in OAuth usually. But it does violate RESTfulness, and that's where part of the controversy starts. When people debate, you can look this up online and read for hours, all kinds of debates on this, by the way. If you're bored sometime, it's interesting. So we use statefulness in practice because we have to have authentication. Your API, to be RESTful, should be cacheable. All the caching information should be contained in the API itself. This is one of the things that we violate on the homework. There's nothing to do with caching throughout this whole course. It's one of those things that I'm like, maybe we should add that to 312, but I don't know. It's kind of boring, to be honest. Caching it's a performance thing. It doesn't give us any extra functionality. It just gives us more performance. And then I have to start grading you on the performance of your apps to a much higher degree. But cacheability we don't do, so we lose some RESTfulness points, I guess, for not having the cacheability data immediately available. It should be a layered system. We get this one in spades. So it should be a layered system, meaning that our API and our users are two parts of this API, of the whole dynamic here. If we add an extra layer in the middle, it shouldn't break anything. If the user wants to go through a proxy, or if we want a reverse proxy on our side, which we will do later in this course, we can add that in front of our API and have the client not directly speak to our API, but by the time the request gets to our API, it should do the same thing. We shouldn't need direct connections with our clients. And we definitely get that the way we're going to set up the way we set up our APIs. And just the way we set up our web servers in general. We get an HTTP request, we send an HTTP response. We don't need a direct line of communication with the client. The client can be bouncing around a whole bunch of VPNs for all we care. We just get the request, we send a response. And we will. By the end of the semester, we'll have we'll have a reverse proxy server, which is going to add our HTTPS. Most of the semester, I'm just going to talk in HTTP, but at the end, we will get HTTPS. We'll get our encryption in there. It should be a uniform interface, meaning that the whole API should be self-contained. We mostly get this. There should be like a root endpoint that gives you all the documentation of how to access the API. So we lose a little bit of self-containment in the API because you need the homework document to understand what the API is supposed to do. That serves as part of the documentation for the API, when it should be completely self-contained. So we lose just a little bit there. But for the most part, this means when you, for example, create a new record, you should respond with that record. So when you create a record, the user's supplying all the information for that record, username and email in our case. But when you process that, when you store that, you're creating an ID, an integer ID, and associating with that record. So when you create a record, you want to respond to the user who created that record with the whole record, including, most importantly, that ID. So now if the user wants to update that record, they don't have to look somewhere else to find the ID of that record they created. They have it right in the HTTP response from our server. So they're just communicating with our API, and they don't have to go to an outside source to find out how to do anything, how to access their data. Upload it, then go to a web page, see their data, look at the ID number that they get. They don't have to do any of that. Self-contained. We want the API to be its own self-contained thing. And that's it. That's the high-level criteria. There's way more detail, more than you'd ever want in the dissertation itself, but those are the high-level points that you should hit to be a RESTful API. So the users are interacting through our RESTful API, and then our server takes those HTTP requests, converts them into CRUD operations, and communicates with the database. So that, in short, is how our users are communicating with the database. They don't store data directly. The users never get direct database access. Our server is going to speak HTTP, and it's going to speak database statements and queries. Any questions on that? That's my last slide from Wednesday's stuff. And the rest of this lecture will be some live demos showing off some stuff. So any questions on this before we shift gears? Actually, I don't have to ask for questions. I can ask you a question. Let me put this up while we're waiting. So this is some of you weren't here when I said this. This is Wednesday's lecture question. I changed the due date of Wednesday's lecture question, so if you did come back after the fire drill, I put up the question, you could have answered it then. If you already answered it, don't worry about it. You already got your answer in. But if you didn't answer it on Wednesday, you can answer it right now. Make sure you answer it under the Wednesday lecture question. This is the Wednesday's lecture question. And since it's not at the end of lecture, I have to decide how long to wait. I forget when I used to do these things mid-lecture, how it can be tough to know when to start up again. But I'm sure y'all will let me know. Looks like most of you aren't doing anything, so I guess most of you did answer it. But how did you get the question if you weren't in the room? What? Did I? I told you I suck at English. I don't do English. Where did I use the wrong there? Right there. Oh, yeah, that's super wrong. I mean, to be fair, it's one of the incorrect answers, so maybe it's wrong because of the English. Does anyone need more time with this? I see most of y'all doing nothing. Good? All right. Okay. So let's get on to some other stuff. Testing APIs and Docker examples. Woo! All right. So this is going to be another demo day. If we got through everything on Wednesday, this whole day would be a demo day. So as always, just a quick reminder, I have like a loose list of stuff in my head that I want to go through, some stuff that I want to show you to get some practical examples on the concepts that we saw in the slides. If at any point you want to see something else, like I'm good with these lectures being guided by all of you. If there's something, especially if there's something a lot of you are struggling with on the homework, let me know about it and I can pivot into that. I don't have to go through the things that I'm going through. The things that I go through are just the things that I think will be most helpful on your homework, but you all know what's going to be more helpful better than I do because you're the ones actually toughing it out through the homework assignments right now. The first thing, though, I do want to absolutely make sure that I show you. So let's do this one. Oh, that's the wrong thing. So I want to... Suppose I could just run this one. Yeah, let me just run this. Screw it. All right, so I'm going to run a server. This is one of my demo servers, the only servers that I showed in lecture so far. It completely ignores the HTTP requests and just responds with hello. That's all it does. So the question that we have when you're doing this API stuff, you're doing application objectives 2 and 3 on the homework, and you have get requests, post requests, put requests, and delete requests that you have to test. How do you test those? What do you even do? So get requests is easy enough. You just punch in the URL in the address bar of your browser, and it'll fire off a get request for that URL. That's what the address bar does. It sends off get requests, and then whatever you get back, it responds. We can test a get request localhost 8080. It responds with hello. We can, something I haven't showed yet. Actually, let me slow down a little on this part. If you go to inspect element or otherwise open up your dev tools in your browser, this is, actually, yeah, I don't think I showed this in lecture at all yet. This is your best friend in, I think I did very briefly because I remember saying that line. This is your best friend this semester. So this is your best friend this semester, though. This is going to have all kinds of information about your app. For our purposes right now, what I want to show is the network tab. You'll spend a bit of time in here, unless you can just one-shot your homeworks and everything works perfectly the first time. This is going to be your biggest debug tool to figure out what's going on wrong with your app when it doesn't work. So if I go to the network tab, I can see I got 2 requests. You'll see these favicon.ico. This is a request for the icon that's going to show up in the tab. We don't have those. I meant to add them to homework 1, and to be honest, I forgot. So there's nothing to respond to there, but the browser will fire those off. If you respond with a 404, that's perfectly fine. My server responds with hello to absolutely everything. So, but if we look at the request, we can look at the headers, and I can see all the headers. This is where I like to look. If it's office hours and a student's like, my request isn't working, I'll ask them to open up the network tab and show me the headers, and usually there's something going on wrong with the headers. Here I got my headers. I can see that they're formatted exactly the way I want. I can see all the request headers for what it's worth. When we get to parsing the request headers, checking what those are can be helpful. But the response headers at this point especially. And you can see them in raw format. I can see exactly what I responded with to see if it all checks out, if it is what I expected to be responded. I can see the body of the response. Hello? Perfect. Then preview sometimes is helpful and sometimes isn't. I think for images, preview will show here and then response won't show anything. I don't know. If there's not what you want on one of these tabs, go to the other one. That's what I do. And we can get all that information from this developer tools. We can also go to the console. This is where anything, like if you do console.log, this is where it's going to be logged to. And any JavaScript that runs, any JavaScript errors, for example, the error messages are going to show up here. And I can actually run JavaScript here. This isn't even HTML. This is just the string hello. So there's not much I can do on this page. You can see the source. Oh, it does change it into, actually, it's not worth it. Another day. We'll do that another day. And all the sources. I can check all of the information for this page, which is just stuff here from my browser, because this page literally just says hello. So nothing really to see. Oh, there it is. The source of hello. This your browser actually does contain a full JavaScript debugger. So debugging front-end stuff, not that we do much of that in this course, but debugging front-end stuff, you have a lot of power right in your browser. Very helpful to debug your front-end stuff. Actually, just used this the other day on Autolab was having an issue with a few students. Actually used the JavaScript debugger on Autolab code to find exactly where the code is that was causing the issue, which hopefully Nicholas is fixing. It's a very rare bug. It's affecting very few students, and we're pretty sure it's an issue with the way their browser is running the JavaScript. The JavaScript's there and everything, but we need to make that JavaScript more robust. My guess, I guess, is that the way their ad blocker is interacting with Autolab's JavaScript. But anyway, I don't want to get down the rabbit hole. But anyway, this is super helpful to have. And what I want to highlight here is this, the headers. But how do we test our API when it's post, put, delete? How do we test those? Well, I'm going to use something called Postman. If you have other ways of testing, be my guest. There are browser extensions, plugins, and stuff. There's other software that'll do this. I'll show Postman. This is kind of the industry standard one. For this, it is very picky. We do see a lot of office hours issues of Postman not liking your exact syntax. Things do have to be exactly right, which, yeah, it should, but but it does cause some issues. It's very, very picky. But Postman, if you get into Postman, one thing, I don't want to update. So one thing that you have to know about Postman is, get to my workspace here, is that new HTTP request is that you have to have the desktop agent running when you're running Postman, which I may or may not have running right now. We'll find out. But when you get into Postman, you want to create a new GET request or a new HTTP request, and then you can type in whatever you want. You have full power over the type of request. You can have full power over the URL and path if I wanted to add a path here. And you have full control over everything that's going to be in that. So if you want to send a body to the request, if you want to add some headers to the request, whatever you want. I'm going to fire this off just to see what I get. And I do get hello. Hello. If I go to the headers, I can see the headers that were responded with. I can check my content length, content type, see if they're what I expected. I can see everything about this request. So I fired off a request to my server and then check the response in Postman. Now, how this helps in the homework is you'll do post request / I always forget if I did user or users. I think it's just user. I'm going to go to body raw JSON, and then I can write the request username Hartloff, email hartloff@buffalo.edu, and I can fire off that post request, and I can see that my server didn't respond with anything. Is it user? I mean, my server doesn't do anything anyway, but it is users. Let me get that on there. My server should have just responded with hello because it ignores every request. It just responds with hello. I'm not sure why I'm not seeing a hello there, but error socket hang up. Well, yeah, it might have. Let me see if it's still running. Oh, it crashed. That's why. That's the next example of why that crashed. Go on. Yeah, so Postman's pretty finicky, but the server does need to be running. I can't blame Postman on that one. but it would respond with hello. I'm not gonna fiddle around with this. But then you go to add your, if I want to change the ID or change the value, I'll change this. I want to change my username. I'll update the record with the ID that I expect, and then send the put request. And you can use this to test to make sure that your API is responding with what it should be responding with, and making sure that all this data is getting in your database the way you expect. So that's Postman. I don't really have too much to say about it. Feel free to poke around and explore all its other features. But just being able to send the requests like this, and when you send a JSON, go to body raw JSON, and that'll give you, what that does for you, by the way, is if I have invalid JSON, it's going to check to make sure that I have valid JSON. So instead of just doing raw text, do raw JSON, and it'll check some of your syntax. Where raw text, this will be valid raw text, it's not valid JSON. Any questions on this? I haven't touched my phone in so long it fell asleep. Does the browser cache redirects? I had an issue. It can. Wouldn't send the old one. So when you're in here, I always do disable cache to make sure you don't get any caching issues. So if you open up your DevTools and disable cache, you should be able to avoid those issues. Yeah, and especially since it's a 301, a permanent redirect, it should be caching it. This is melting my laptop. My fans are spinning up. I don't know what it's doing, but I don't like it. Yeah, I'm done with Postman anyway for the example. You get the idea at that point. About the username and password part? What's the next part with users and passwords? I don't know what you're saying. You mean in Postman? On VS Code. Oh, yeah. No, that's the next example. That's the next example I want to show. 3, yeah, we got time. We'll get to it. So when you do use Postman, the one thing I wanted to close up the other thing I was saying. When you first do this, if you do exactly what I just did, you'll have to create an account and everything first, and then go in here. You're going to get an error. It's going to say you need the desktop agent running, and it should just give you a link. You click the link, install the desktop agent, make sure that's running. Then once that's running, then you can start sending off your requests. But there's an extra step in there. This is the agent telling me to update it. It is running, but it just needs to be updated. So just a heads up on that. Now I'm done with Postman. Actually, I lied a little bit. That's not the next example. I want to show this one. I meant to show this off earlier. I didn't quite get there. Yeah, this is the right thing. Let's close this server. Force it closed. Servers, encodings, Python 3 files. So let's run this code. Let's resize this. Oh, come on. Can't tell where I'm pointing with this giant cursor. So I have code. I have 3 separate methods that are all going to copy a file. I'm going to copy this beautiful Twitch logo. Let's just do copy file first. We'll do the first one. It's the Twitch logo. And I'm going to copy it into a file named copy.png. Let's delete this to verify that we are actually creating a new file. Come on, delete. Go away. You're kidding me. Come on. Let's delete it. Let's run this code. We get our copy back, and it's a straight copy of that file. The way I did that was with this code right here. I opened the file in byte mode, very importantly, in byte mode. I read the bytes of the file, and then I wrote the bytes of the file to a new file. So, of course, you'll be reading the bytes of a file and then appending them to the end of an HTTP response. But just as a proof of concept, I'm just reading the bytes and then writing the bytes. And that's it. I read the bytes of one file, save those bytes in another file, I copy the file. Easy enough. Let's do this another way. Let's do bad 2. And I want to copy this again. It should overwrite the file. Just to make sure. Oops. Stripe gives me an error. Cool. Why wasn't I ready for that? I ran this code, right? Maybe I didn't. Anyway, so I did bad 2, and I get an issue here. I'm reading the file, not in byte mode. And when I read the bytes of this file, Python's weird like this. Sometimes it crashes and sometimes it just doesn't. In the next example, it shouldn't crash. But this one it does. When I call read, since I'm not reading this in byte mode, it's trying to read the file as a string. And the error I get is a UTF-8 error. It's trying to decode the bytes of an image as a UTF-8 string. Now, UTF-8 strings have to be encoded in a specific way. Either a byte starts with a 0 and it's an ASCII character, or it starts with 1, 1 and the next byte is 1, 1, 0, and then the next byte starts with 1, 0, etc. Like there's a specific format. So if you take the bytes of an image, it's almost certainly, aside from some absolute stroke of luck or bad luck, because things would break, it's not going to be encoded as valid UTF-8. So we get this error, can't decode it as UTF-8. So we can't copy the file like that because we're trying to read an image as a string, and that won't work for us. It's never going to work for us. You can't do that. Your images are not strings. Have I got this point across enough yet? Images are not strings. I've talked about this a few lectures. Let's use copy file bad. This same thing, but we're not going to get an error this time. We get our copy of the image, but guess what? It's corrupted. It's not a valid image. All I did was take the bytes here and copy them here, right? It's not a valid image because this time, while I read it in binary mode, that's cool. All right, I read all the bytes, I got all the bytes of the file, and then I converted it to a string. Python's weird like this. Sometimes it's errors, sometimes it doesn't. I converted this to a string, and at that point, I'm trying to convert an image as a UTF-8 string. It doesn't work. We know that doesn't work. But in this case, Python's like, I'll try to just guess what these bytes mean. And it returns a valid UTF-8 string, but it destroys all of the data of our image. It's a valid UTF-8 string now because it just changed the bytes. I don't know how or why it does that, but it just says, I'll figure it out. And it gives us something. So we got something here, but it is not our original image. These are different bytes. So now when we encode those bytes back into binary, we have this ASCII string that we're encoding back to binary, UTF-8 string that we're encoding back to binary, but it doesn't give us the original bytes of the image. That image is corrupt now. We destroyed that information. It's not the same image, so when we write to this file, we don't get any errors, but we also don't get our image. So if you're ever, at any point, taking the bytes of your image, this is for application objective 1, of course, taking the bytes of your image and converting it to a string. I seen an issue in office hours earlier this week of not really explicitly converting to a string, but using using the string formatter in Python, having a string placeholder and then giving the image as the value for that placeholder. Well, that's going to convert it to a string, even though you don't do explicit string of and convert to a string. If at any point you're converting the bytes of that image to a string, you are losing information. You're corrupting the image, and the user's not going to get the actual image. Very, very important to never, ever, ever convert your bytes of an image to a string, or any non-string data into a string. It's going to corrupt the data. That'll be a theme throughout the course, at least through homeworks 1 and 2. Never, ever convert your image into a string. It will break things. And hopefully it crashes. I'd rather it crash than just silently give me errors. But sometimes it'll just silently give you errors. Okay. If anybody was asking for a MySQL example, here it is. So I mentioned MySQL, but I didn't show how to set it up in Docker and Docker Compose. It is a bit more work than MongoDB, one of the reasons I recommend MongoDB. The Docker file is all going to be the same. Requirements, I'm going to install my MySQL library instead of a MongoDB library. My server code is mostly the same except for interacting with the database. And my Docker Compose, this is where I want to start with the explanation. So instead of pulling from a MongoDB image, I'm going to pull from MySQL. I decided to take MySQL 8 and whatever version they want to give me, whatever, probably the latest version of 8. And with MongoDB, that was it. You know, we can expose the port if you want to install some MySQL database viewer, some software that's going to let you visualize and interact with your data in a better way than command line. You can expose the port. But that's it. That's all we had for MongoDB. With MySQL, we have to have a little bit more work to be done. When you fire up MySQL, when this container is created from the image, it's going to look for a variety of environment variables to do the initial setup of MySQL. If you've ever downloaded MySQL and installed it on your machine, it'll ask you a series of questions, mainly to set your root password and what's the name of your database, the two things we're setting here. And then you can also set up a separate account that's not the root account. You can't answer those questions when you're running this in Docker Compose, so we set them as environment variables. We set our answers to those questions as environment variables. So I'm going to name my database. I'm just going to name it DB, because whatever. And then set the root password. If you want to set a MySQL username and a password for that username, feel free to look up the documentation, what those environment variables are called, and set it up like that. I'm just going to use the root password to keep this as simple as I can. And whenever I set a password that's going to be in a repo like this, I always set the password to change me as a very, very clear indication that you need to change this password. If you're going to use this software, deploy it on a server, you need to change that password before you do anything because everybody has access to this password. But we have that password in one file, in the Docker Compose file, so at least it's easier to change instead of looking through thousands of lines of code to figure out where it's hard-coded in your code. When this when this container is created, it's going to read these two names, and these have to be exact, absolutely exact character for character, because it's reading these exact variables. It's going to read these variables and use these for the database in password. Then in our app code, it's generally good practice to not have the password hard-coded in your actual code. We don't want passwords in our code because if our installation instructions when someone goes to deploy is look at line 147 in this package and this file and everything, that's bad. But if we put it in one file, we have all our configuration in one file, or even better, having these outside Docker Compose and have a settings file that are going to be read. That's what we want to do, get these out of the code. So I'm going to put the same password here as I have here, and then in my code, I'm going to read this environment variable. And as always, we have our wait hosts on MySQL. Then in our code, I'm going to use my connector, and this is just reading the documentation of the MySQL connector. It's going to want the host. The host has to match whatever we have right here. We can name that whatever we want as long as it matches. I'm using the root user. The database is going to be DB because that's what I called it right here. And the password, I'm going to read this environment variable. I set an environment variable in my container. I'm going to read that environment variable and use that for my password. Don't hard code your passwords right here. That's bad. Don't do that. Just don't do that. We're going to read the environment variable, and then we can have our passwords stored in environment variables, not in our repo. Yeah, technically the Docker Compose in this case will be in our repo, so it's still not the best. But when we want to change the password, we change it in Docker Compose and don't touch the code. So when we go to deploy, we change the password. And I'm going to create a table. I'm going to insert into that table, and then I'm going to grab everything from that table and print it to the screen just to show that just to show that this thing's working. So let's build this thing. I'm going to fire off a request. I should get hello. Fire off a bunch of them. And then when that code runs, I can see when I get my data from my database, which I'm storing the host and port, I can see that I am actually pulling that data from the database. This is a proof of concept that I am interacting with a MySQL database through that container. There are a few things I want to talk about with databases in general. I'll let this stop gracefully just to make the point. MongoDB didn't need any passwords, was the big difference. Yeah, use your prepared statements. I have a prepared statement. It's not question marks in this library, it's %s. So I ran this again. I'm going to access the site again. And what you'll notice is that all my data is gone. When you rebuild the container, all your data disappears. It gets wiped each time. If you don't rebuild the containers, if you don't redo Docker Compose up will, when I stop them and redo it, it will blow away all my data, even without the dash build and dash force recreate. So your data will get blown up. One bug that I experienced, regrettably, with MySQL that I'll prepare you for any of you, if you are using MySQL. I want to change the password. I just change the password here, change the password here. I just confirmed that my data is getting blown away every time I recreate the container. So it makes sense that the container is getting rebuilt every time, right? I would think that. Would you think that? You'd be a fool to think that, right? I think that would be a reasonable assumption. The data is getting blown away. But I'm getting an error now that my password's incorrect. The password does not get reset when the container is rebuilt. This drove me nuts for several hours. You actually have to go into, there are other ways to do it, but if you go into Docker Desktop, actually delete the containers and then rerun it, that's the way to actually change your password. And now I can connect to it, and now it works. So be aware of that if you're using